Assalamu alaikum, uh, dear students. As we know that we'll have to take the classes, online classes. So, for this purpose, I'm recording some of the videos for your lecture, so that you can review all the lectures and topics that we'll have to cover in this course, differential equation. So first of all, I'm defining the definition of the differential equation. That an equation that is involving a dependent variable. Of course, in any equation we have one dependent variable for our consideration of the differential equation. We have one different dependent variable. We might have more than one independent variables, or maybe one independent variable, and the differential operator, and it must not have any arbitrary constant. So this is the definition, this is the complete definition of the differential equation, that it contain a dependent variable, independent variables, differential operators, and it doesn't contain, it will not be having arbitrary constant. Okay, so whenever we are considering that uh, about the differential equation, we have two types of the differential equation. First of all, differential equation is classified as ordinary differential equation, and the second is classified as partial differential equation. In the ordinary differential equation, we know that we have only one independent variable and one dependent variable. For this ordinary differential equation, we will have one independent variable and one dependent variable. For the partial differential equation, we have the same criteria of the different dependent variable, that we have we'll have one dependent variable, but we may have more than one independent variables. So these are the classification of the differential equation. Now, for the sake of our simplification, we'll have to study ordinary differential equation first, and then we'll study partial differential equation, about the partial differential equation. So topic that today we'll cover the topic of ordinary differential equation. We'll start whenever we are saying that we have to study differential equation, that means we have to study in two domains. The first domain is of the study is the formation of the differential equation, and the second is study of the second domain of the study is the solution of the differential equation. In this lecture, we'll only cover the formation of the differential equation. So we are starting the formation of the differential equation, and of course the ordinary differential equation. The formation of the differential equation consists of three steps. The first step of this formation is you have to count the number of arbitrary constant in your equation. The second step of your formation of the differential equation is you have to differentiate the given equation by a number of arbitrary constant times. That means if in any equation you have if you have two arbitrary constant, that means you have to differentiate it two times. And if you have in any equation, if you have three arbitrary constant, that means you have to differentiate it by three times. We'll always differentiate with respect to the independent variable. Okay, so after these two steps, we have to eliminate the arbitrary constant if they exist, if they still exist in the differentiated equation. So for these steps, for this understanding of these three steps, I am giving you one example. The first example is, if you have an equation y is equals to a cos x plus b sin x, that means we have two arbitrary constants in this equation. The first arbitrary constant is a, and the second arbitrary constant is b. Now that means we have to differentiate this equation by two times. If we differentiate it first time, if we are differentiating this equation first time as with respect to x, since in this equation we can see the dependent variable is y and the independent variable is x. For the book study or for the lecture delivering, it's a standard, it will be the standard that will consider x as an independent variable and y as dependent variable. Or in any other case, if we'll have to consider any other situation, like for any reason we consider y as independent variable and x will be the independent variable, then I'll notify it. Or for any other equation, let's suppose that we have equation as y is a function of t. That means I am defining here it as the t is your independent variable and y will be your dependent variable. If for any case, let's suppose if I am defining k is a function of phi, that means phi is your independent variable and k is your dependent variable. But for any other equation that are not consisting of y and x, that means in this situation I'll always define that this variable is independent variable and this variable will be the dependent variable. Okay, for this instant, for this equation y equals to a cos x plus b sin x, we know that we have two arbitrary constant. That means we have to differentiate it two times. Okay, in the first differentiate, the result of the first differentiate with respect to x will be y dash, that is equals to a, the derivative of the cos x is minus sin x, plus b, the derivative of the sin x will be cos x. This is the first derivative or the first differentiate of the equation if we differentiate the equation with respect to x. Now for the second derivative, we have equation as y dash equals to minus a sin x plus b cos x. We are considering this equation as equation number 2. If we again differentiate this equation, again differentiate equation 2 with respect to x, that means the result will be y double dash, or we can write it as d square y divided by dx square will be equals to a minus a cos x minus b sin x. Now this will be the equation 3 for our consideration. We have these three equations, as the first equation was y equals to a cos x plus b sin x. This is our equation number 1. Now for following the third step, that was the step of the formation, we had completed the second step, the differentiate. We have to differentiate the given equation by number of arbitrary constant times. So we had differentiated the given equation y equal to a cos x plus b sin x by 2 times. Now we have to follow the third step, as we have to eliminate the arbitrary constant if they exist in our equation, and this elimination must be a case of a substitution by elimination by substitution, or any other process that we can consider it, or elimination by any of the by using any of the mathematical property. Okay, let's suppose we want to eliminate these a and b. We can evaluate the value of a from the equation number 3 and then substitute it in equation number 2, so that the equation number 2 just contain the value of the b or arbitrary constant b. So this value can also be substituted or evaluated the value of b, and then substitute in equation number 1 in the value of the a and b can be substituted in equation number 1, so that we can eliminate the arbitrary constant. But it's a lengthy process of the substitution. We know that the process of the substitution takes too much time. So if we consider the equation number 3 or look closely at equation number 3, we can see that if I just take a minus as a common from the equation number 3, so you will have a cos x plus b sin x. So from the equation number 1, this whole part is equals to y. From the equation number 1, this is from equation 1. So just substituting the value here, we'll have minus y double dash, or we can write it as y double dash plus y equals to 0. This will be the required formed differential equation. This is our final target, or we can write this equation as d square y divided by dx square plus y equals to 0. So this is the first example of the formation of the differential equation. Let us consider that let's suppose if I say you have to form a differential equation of ellipse by using its standard equation or any equation of the ellipse. So considering the equation of ellipse as x square divided by a square plus y square divided by b square equals to 1. This is the standard equation of ellipse, in which we can see that we have only two arbitrary constant. Now we have to eliminate these two arbitrary constant after the differentiate the process the step number 2 of the formation of the differential equation. We can see here that the number of arbitrary constants are 2 here. This is the step number 1 of the formation of the differential equation. The step number 2 is we have to differentiate the given equation by 2 times first here. So for our simplification, if I take the LCM of this equation, or we can reformulate this equation as b square x square plus a square y square equal to a square into b square. Now for this is only the simplification of the above equation. I am saying this equation as this is equation number 1. Okay, now so I have to differentiate this equation number 1 by 2 times, so because we have two arbitrary constants here. So we are just differentiating. We have equation b square into x square plus a square into y square equal to a square into b square. This is as equation number 1. So differentiate equation 1 with respect to x. If we differentiate this equation with respect to x, we'll have 2b square x plus 2a square y into y dash equals to 0. Since we know that the derivative of or the differentiate of x square, the result of the differential of the x square will be 2x, and the result of the differentiate of y square will be 2y into y dash. So I'm just writing it as directly here as 2a square y into y dash equals to 0. The derivative of the constants, these are the arbitrary constants, is equals to 0. I'm just taking 2 as a common, so we can rewrite the equation as b square x plus a square y into y dash equals to 0. We are taking 2 as a common and shift it towards the right side. So and now again this is equation number 2. We are differentiating equation number 2 with respect to x again. So if we differentiate this equation number 2 with respect to x, we'll have b square plus a square. We'll have to use u into v, the product rule of the differential here, as y into y double dash u derivative of v will be y double dash plus v, that is y dash, into derivative of u is y dash again. So we can rewrite it as b square plus a square into y double dash plus y dash whole square equals to 0. So from this equation we can say this is equation number 3. We had completed steps the second step of the formation of the differential equation here. So from this equation, if I evaluate the value of the b square as minus times a square into y double dash plus y dash whole square. Now we just have to substitute this equation b square into any of the other equation number 1. We have a choice to substitute it in equation number 1, or we have also a choice to substitute in equation number 2. I am considering the equation number 2 for the substitution of the value of the b square. So just substitute the value of b square in equation number 2. So if I just substitute the value of b square in equation number 2, it will be minus a square into y double dash plus y dash whole square plus a square y into y dash equals to 0. Now I can take y a square as a common from this equation. So a square is taken common. The remaining equation will be minus y into y double dash minus y dash whole square plus y into y dash equals to 0. So I can just transfer this a square to the right hand side. This equation will be only y into y dash minus y into y double dash minus y dash whole square equals to 0. This will be the required differential equation of the ellipse. So it's your target or it's your practice question to form the differential equation of hyperbola. Differential equation of hyperbola. It's simple, since the equation of the ellipse and hyperbola has nothing different except a minus sign here. So it's your target to form the differential equation of the hyperbola. Let us consider the one another example as okay, let us consider another example of the formation of differential equation as if I say you have to form the differential equation of circle that is passing through origin. This is basically an example of this circle that is passing through origin. This is a rough diagram of this representation. That means we can consider the general equation of circle, that is x square plus y square plus 2gx plus 2fy plus c equals to 0. This is the general equation of circle. And if we say that this equation of circle sorry, or the circle is passing through origin, that means this equation will satisfy this point. Of course, it will satisfy all the points that are containing on the circle. This is the basic definition of the equation, that it will satisfy all the points that are containing of that particular curve. So if we say this equation is the general equation of circle, it will satisfy the point origin if it's passing through origin. So for this we can substitute the value of x as 0 and value of y as 0 in the particular equation. We'll get a condition of c equals to 0. That means the equation of circle that is passing through origin will be x square plus y square plus 2gx plus 2fy equals to 0. So again we have two arbitrary constant. That means we have to differentiate differentiate the above equation 2 by 2 times with respect to x, of course, and then we have to eliminate the arbitrary constant. So this is your target to form the differential equation of circle.